Hello, so today we're going to be looking at this question, which is from the 2024 AI Higher Level past paper. It's an optimization question, so for if anyone is struggling with optimization, this question may help. So this question says a shop uses the following model to estimate N, the number of smoothies sold per day, in terms of X, the price of a single smoothie in pesos. The maximum number of smoothies the shop can make in a day is 400. Part A says find the maximum price they could charge per smoothie to sell 400 in one day. So we know that N must equal 400. So we simply solve 400 equals 40,000 over x squared. And if we just type this into our calculator, we will get that x squared will equal to 100. So we have that x will equal plus or minus 10, but as you can't sell for a price of negative 10 pesos is the maximum that they can sell for. So that's our answer to part A. Now part B1 says on one day when the shop sells smoothies at 50 pesos each, use the model to find the number of smoothies sold. So we know that the denominator will be 50 squared, giving us 40. Sorry, one sec, my pen is acting up. Giving 1 second. Alright, sorry. So 40,000 over 50 squared, which will then result in 16 being the number of smoothies sold. And part 2 says the total income from the smoothies sold. So total income will just be 16 times the cost, the price, which is 50, which results in 800 pesos in total. So now the question gets a bit more interesting. It says the cost of making each smoothie is 20 pesos. The profit per day is the total income of the sales minus the cost of making them. Show that according to the model, P equals 40,000 over X minus 800,000 over X squared. Alright, so we need to know that profit equals revenue minus cost. And revenue will be equal to, so revenue is units sold, which is N, times the price, which is X, minus the units sold, 1 second, times the cost per unit sold. So we now know that to solve this part, we just have to substitute the function for N back in. So we get 40,000 over X squared times X, so the X's cancel, minus 40,000 over X squared times 20, and these two multiply to make 800,000. So we can simply write that as 800,000 over X squared. So now it says find dP over dx. Now to do this, we're going to have to rewrite this and apply the product rule. The power rule. So this is simply 40,000 times x to the negative 1 minus 800,000 times x to the negative 2. So now all we have to do is just differentiate this, which gives us negative 40,000 x to the negative 2 equals, minus plus 160,000 x to the negative 3, 1.6 million, my bad. So we can now just rewrite this back in fraction form as negative 40,000 over x squared plus 1.6 million over x cubed. So it says find the number of smoothies sold when the profit is maximized. So there are a couple of ways to do this. First, you can just graph this function and find the maximum of point of this function. So if we try it with that method, we simply have to go to our GDCs and input it, which doing so will give you a graph that looks something like this. And if we are to find the maximum profit, we can just see that we evaluate it at a large value of x. So zoom out on your graphics calculator and simply just type in the x value at 40 or something, and that gives you a large value here. But there is a much more efficient way to do this. So we just take the derivative function that we have here and we set it equivalent to 0 because at that point it will be flat, and flat means that it will have reached a minimum or a maximum. So if we equate this to 0, we will get the points at which we will have the maximum profit. So we just say negative 40,000 over x squared plus 1.6 million over x cubed. And then we simply just go to ycal on our calculator and set it to 0. And we let the calculator do its thing for a little bit. And it gives us the value of x as being 40 when y is equal to 0 for the derivative curve. So we know that when 40 cans are made, we get the maximized profit. So f prime of 40 is equal to 0, and hence 40 smoothies are sold. Alright, that's it for this question. Thank you for watching. I hope you found this helpful, and see you in the next